Now let's go ahead and chat about how to come up with the law of cosines here. So we've drawn our perpendicular line straight down from this top corner up here. And what I'm going to do, my strategy here is I'm going to go ahead and use the Pythagorean theorem for this rightmost triangle that is a right triangle right here. And I'll also use the law of, or my trigonometric functions for right triangles. Okay, so let's start by using the law, or the Pythagorean theorem for this right triangle that is to the right of my big triangle. That is the triangle in yellow here. So the Pythagorean theorem says that h squared plus, and now I need a name for this little side here. So I'm going to call, and maybe I want to give myself a little bit more room. So I'm going to call this length here y. So h squared plus y squared, that has to be equal to the hypotenuse squared, and the hypotenuse in this case is a squared. Now, when I see this h squared plus y squared is a squared, I want an equation that only involves the variables that were originally there. That is a, b, and c, and alpha, gamma, and beta. So I want to go ahead and relate h and y to things that were originally there. So what we can do with h is, well, there's a number of things that we can do. The thing that works for the law of cosines is, first, I'll notice that sine of alpha is h over b. So sine of alpha equals h over b. And that will allow me to write what h is in terms of things that were originally there, b and alpha. So h equals b sine alpha. So I can go ahead and put this into my equation here, and I get that b squared sine squared alpha plus y squared is equal to a squared. Now, if you're sitting there wondering why or how would you know how to do that, don't worry too much about understanding all of these steps that I'm about to do, in the sense that, okay, I need to memorize how to do all these steps in order. Know how to do each individual step. That is, I would say know that why it's true that sine alpha is h over b from the drawing, but don't worry yourself so much as to memorizing how to do all these steps to come up with the law of cosines. Okay, so now I have this y in here, and y wasn't originally there, so I want to get rid of it. So I'm going to do a little bit of magic to get rid of this. So I know that this length here is c, and I know that this length is y, so that means that this length here is going to be c minus y, because if you take c minus y and add y, then you get the total length of c here. And then also, cosine of alpha is c minus y over b. So cosine of alpha equals c minus y over b. And now again, I wouldn't expect you to come up with this, but what I do expect is if you had this picture in front of you, you could tell me why cosine of alpha is c minus y over b. Okay, so that means that y is equal to, well, I can multiply by b, subtract c, I get b cosine alpha minus, I think this is going to be negative y, because I multiply by b and subtract c, negative y is this, so I can multiply by negative 1, and I get that y is negative b cosine alpha plus c. And now, look, I've written y in terms of things that I know, b, alpha, and c. I can go ahead and take this and put it into here, and what I get is that b squared sine squared alpha plus, then I get y squared. Y is going to be c minus b cosine alpha, c minus b cosine alpha squared is equal to a squared. Okay, now let's go ahead and work with this expression here. Notice that this expression only has things that I initially started out with, b, alpha, c, and a. Okay, so I can go ahead and FOIL this c minus b cosine alpha, and what I get is b squared sine squared alpha plus c squared minus, now when you FOIL this out, you get, okay, so let's just write all of this. So c minus b cosine alpha, c minus b cosine alpha, that's going to be c squared, that's the first term, minus bc cosine alpha, minus another bc cosine alpha. This is from the inside and the outside terms, and then plus b squared cosine squared alpha. And so this is going to be b squared sine squared alpha plus c squared minus 2bc cosine alpha. Notice this, 2bc cosine alpha, that shows up in the law of cosines. That tells us that we're close. Plus b squared cosine squared alpha. So that got me, this term is taken care of, these two terms are taken care of, and this is taken care of. So I got this, and this is equal to a squared. And now the last step here is I'll write a squared, got that, equals, I'm going to go ahead and factor a b squared out of both of these terms. So b squared times sine squared alpha, that's that term, plus cosine squared alpha, that's that term. Then I need plus c squared, got that, minus 2bc cosine alpha, got that. And what do we know about sine squared alpha plus cosine squared alpha? It's equal to 1. And so this is a squared is b squared plus c squared minus 2bc cosine alpha. And you can derive the other ones in a similar way. I'm not going to go ahead and do that, but if you're feeling crazy and you want to, give it a shot.